Hello, in this video we'll talk about the different technologies we used in the SLIC pilot projects. I shortly introduced the 7 SLIC pilot projects in the previous video, and in this video we'll discuss the technology we used, and we will also discuss the project results that we managed to achieve in the SLIC project itself. So first up is the pilot project in Amiens, where we have 80 light posts, and these light posts were equipped with various sensors. So we used infrared motion sensors, we used radar detectors, and we also used optical sensors to be able to see if there's a car or a pedestrian coming, and then based on that data we can turn on the lights or increase the light level if the lights were already on. In this case we illuminated different roads and also a tunnel. The tunnel of course brings its own challenges because there also always needs to be a certain light level to guarantee the safety, and then we used those sensors that I just mentioned to illuminate the roads and the tunnel based on these different sensor data. In Bruges, the situation from a technological standpoint was a little bit simpler because this is an urban area. The lights are always on, and the municipality had a request to simply replace all their existing light posts, which are 2700, with simple LED replacement. The difficulty here was that those light posts are in a historic city center and they need to be replaced by an LED light which looks exactly like the old light. So there the city installed new LED lights which were made to look exactly like the old ones. So they fit nicely into the historic city center of Bruges. In Etteleur, a rural area, and there the SLIC project enabled the LED replacement of 26 streets. And some of them were fitted with motion sensors to be able to dim the entire street based on oncoming traffic, and dim the lights again when there is no traffic detected. Remarkable in this project was that we have very active involvement of inhabitants and also road users to determine the optimal dimming schemes for their street. So this is a rural area, there are not too many people that live there, and the city of Etteleur involved those inhabitants to determine the optimal dimming scheme for their street. Remarkable outcome here was that they were actually able to dim the lights much lower than they would have thought before the start of the project, because the local inhabitants really liked the low light levels that they introduced. In Mechelen we were automatically generating dim profiles, and those dimming profiles were optimized for simultaneous savings of energy and safety of the inhabitants as well. So we try to combine those two things. We want to make the street as safe as possible by enabling a relatively high amount of light, but we also want to save the highest amount of energy. So we looked at a lot of data from the traffic density, the amount of people on the street, to be able to achieve this. In Roeselare, as I mentioned before, we installed an off-grid lighting system for a bicycle path. In this path there are 32 LED lights with motion sensors. And this basically is a tracking light system. So there is a bicyclist approaching, and that means that the light goes to full brightness when the cyclist is underneath the light post and a few light posts ahead of him as well. The system is coupled to a solar power installation. 10 kilowatts of solar powers are installed on a nearby building, which is connected to a 14 kilowatt hour battery storage. And with this system we were able to provide this lighting path, this bicycle path with light during the entire winter. So this system was fully off-grid for a whole year, and there were no problems with the energy production or consumption of the lighting system. In Suffolk we did LED control via traffic radars. There are 850 street lights being controlled by around 25 street radars. The street radars measure the traffic density, and one radar is controlling dozens of lights to enable to determine their brightness based on the density of traffic on the road at that moment. Suffolk is still conducting experiments because they also are trying to control the side roads based on the data from those traffic radars as well. In our last pilot project in Veurne, we had an industrial area where the dimming schemes were based on the activity of local businesses, basically looking at shift work in a nearby factory. and then adapting the dimming schemes to the shift work of the factory workers that are in the local business. There is also a bicycle path through an adjacent area, and in this area there is a really strong urge to minimize the impact on the wildlife. So in this bicycle path, all lights are off unless one of the sensors detects a bicycle, and in this case this leads to a minimum disturbance of wildlife.